Hello students, I am going to explain topics in applied physics. The first topic is quantum mechanics. In this quantum mechanics, these are the topics and all this free electron theory also included in this quantum mechanics. So how the quantum mechanics came into existence? In 1800s, there are many questions that existed and which cannot be explained by the theories existed at that time. In 1838, the discovery of cathode rays. These are identified by Michael Faraday and first he observed in his experiment, but he couldn't identify what those rays are. And in 1859, the black body radiation. First it is identified by Kirchhoff and couldn't explain. And in 1877, Boltzmann identified the energy states are discrete. And then Hertz, while doing experiment in 1887, he observed photoelectric effect. So to explain these phenomena, the theories at that time existed like Newton's laws, Kepler laws, thermodynamic laws couldn't be explained. These laws are used to explain about the movement of the particles, how their state is changing, all these phenomena. But by using these theories, phenomena like hydrogen spectrum, black body radiation, the Stark effect, Zeeman effect, these phenomena couldn't be explained. In the mid of the 19th century, that is 1850 to 1890, along with Max Planck, Boltzmann and some other scientists, energy radiating by an atomic system is divided into discrete energy elements. That is, energy is discrete. It is not continuous. So the Max Planck assumption and the Einstein assumptions have brought a new revolution in the physics world. So by using the Newton's laws, many phenomena were explained which we can see through our naked eye and which we can experience in our day-to-day life also. That all comes under the classical mechanics. The gravitational force, the Newton's laws, Kepler laws, the thermodynamic laws, the one-dimensional elastic collision, all that comes under the classical mechanics. This couldn't explain some phenomena like stability of the atom, spectral series of hydrogen atom, that is Lyman series, Balmer series, Paschen, Brackett and Pfund series, the black body radiation and non-relativistic motion of the atoms, electrons and protons, the variation of the specific heat of the metals and gases. For gases, we know there are two different kinds of specific heat, that is Cp and Cv. Why this variation exists? The photoelectric effect, Compton effect, Zeeman effect, Stark effect, Raman effect, etc. Many phenomena this classical mechanics couldn't explain. By using the Max Planck theoretical statement that energy is discrete. Energy is discrete. By using this thing, now the scientists started to explain these phenomena. Now let us see what is meant by energy is discrete. So, according to classical mechanics, it has taken that energy is continuous. Energy is continuous means all the energy that exists, it will take all the values between that minimum and maximum. But Max Planck has given a paper that on the theory of the energy distribution law on the normal spectrum, it has stated that energy is not continuous. Energy is discrete according to this quantum mechanics. That means it will take only in between values, random values, and it will take the integral multiple values, not all the values it will take. So from this statement, the structure of the atom is explained like, we know that electrons revolve around the nucleus. As long as electron revolves around the nucleus, its energy is constant. These orbits are called the stationary orbits. So after the first orbit, the electron will be going to the second orbit, and in between this first orbit and second orbit, there is a forbidden gap. So energy is not continuous. It is having discrete values, and whatever the phenomena that came all comes under a new topic called quantum mechanics. Hence, quantum mechanics successfully explained many phenomena, that is photoelectric effect, black body radiation, Compton effect, emission of line spectra, Stark effect, like when an electric field is applied to an atom, there is a change in that line spectrum, that is Stark effect. When we apply the magnetic effect, there is a change in that line spectrum, that is Zeeman effect. So these all these questions that are explained by using this quantum mechanics. So the only reason to explain all these phenomena is Planck assumption, that is energy is discrete. So with the invention of this quantum mechanics, nowadays we are able to enjoy many things like the semiconducting devices which are used in the computers, cell phones, etc., the lasers, CD and DVD players, and the barcode scanners, surgical applications, MRI technology, nuclear reactors, atomic clocks, and electron microscopes. All these work with the movement of the particles, which are explained by using this quantum mechanics. And moreover, this quantum mechanics mainly works with a constant, that is called Planck's constant, which is equal to 6.625 into 10 power minus 27 erg second. This is CGS unit, and in SI units it is 6.625 into 10 power minus 34 joule second. So mostly we'll go with this SI unit only. So 6.625 into 10 power minus 34 joule second, which is the Planck's constant value. We'll use this constant in every aspect while working in this quantum mechanical phenomena. So this is the origin of the quantum mechanics. We'll see in detail one by one concept in the further classes.